Okay, so armed with our formula, let's go ahead and practice it in some situations. Hopefully you guys notice that I steadily get harder as we move forward, just to kind of try to cover all the bases. But again, we have a nice handy dandy formula. So to find what values of x solve this equation, I first begin it by identifying what a is. Well, in this case it's 1. What b is, it's 8. And what c is, it's negative 20. Alright, and so all I got to do is come over to my formula and start plugging things in. So we have negative whatever b is, well that's 8, plus or minus, take b and you square it, and you subtract 4 times a times c, and that's all over 2 times a. So now I've plugged it in, now we do the math. So we get negative 8 plus or minus, 8 squared is 64. Here we have a minus, but we also have a negative. So we're going to have a plus, and then 4 times 20 is 80, all divided by 2. And if we keep going, this is negative 8 plus or minus 64, and 180 I believe is 144, all over 2. And so we get x equals negative 8 plus or minus 12, all over 2. And so we have two solutions. One of them is negative 8 plus 12 over 2, and the other is negative 8 minus 12 over 2. And when we do our math here, we get 4 over 2. So one of our solutions is 2. And over here we get negative 20 over 2. One of our solutions is negative 10. And again, you can plug that in to check it out and see that in fact they actually work. But there's our solutions using the quadratic formula. So there's still a lot of work to do, but it sure beats the heck out of completing the square. Although I would argue completing the square is not too bad here, right? It already has what we have, and you might go back and look at the work and see it's actually easier. But you know, it's all relative. The next problem, again, the way it's written, a is equal to 2, b is equal to 40, and c is equal to 200. Now, before we go popping that in there, right? Notice these numbers are pretty large, and so. How about we take advantage of the fact that everybody's divisible by 2, and what we have is x squared plus 20x plus 100 is equal to 0. And what's nice about that is that we have a nice situation where we still have some pretty big numbers, but now a is 1, b is 20, and c is 100. So be taking a look for that. You know, if you have an opportunity to get rid of a GCF, take advantage of that, because it's going to help us with our calculations later. So our solutions are negative b plus or minus, I'm going to take my b and square it, minus 4 times a times c, all over 2 times a, right, which is that. Keep going, we get negative 20 plus or minus, well 20 squared, that's 20 times 20, that's just 400. And then 4 times 100 is also 400, all over 2. So what we end up with here is 0, so that actually goes away. So our x is negative 20 over 2, which means that x is negative 10. Okay, and again, I think we solved this in 11.1 using the completing the square process and got the same solution. I think the same thing here. So go back and look at our intro for completing the square, and you'll notice that we have 2 ways now to solve these equations. We actually have 3 because they'll both factor too. So lots and lots of ways to do this. Here's one that did not factor very well for us. So what does it look like? Well, again, a is 2, b is negative 1, and c is a positive 2. So plugging that into my formula, x is equal to, we're going to negate negative 1, we're going to subtract, or excuse me, add or subtract negative 1 squared minus a 4 times a 2 times a 2, right, a and c, all divided by 2 times 2 there, right, because a is 2. So there I am plugging things in. The rest is just cleaning it up. So we have 1 plus or minus, well, negative 1 squared is 1. 4 times 2 is 8, and 10 times another 2 is 16. So we end up with negative 16 all over 4. And so this now becomes x, 1 plus or minus the square root of negative 15 all over 4. And one last cleanup here. This is x equals 1 plus or minus I square root of 15 over 4. And again, I believe we solved this using the completing the square process and got the same answer. Here's what that would look like if we used the quadratic formula. And clearly, in this case, the quadratic formula is a lot easier to use. All right, so there's our answer. And again, remember there's two of them, right? There's one plus this over 4 and one minus that over 4. So don't forget there's two answers because of the plus minus. Last one for this page. We're going to solve this. And again, I would like to say A is 3, B is negative 15, and C is 6. But I'm going to take advantage like I did up here. I noticed that everybody's divisible by 3. So before I start plugging things in, we can probably make our life a little simpler by dividing everybody by 3. And I don't know about you, but I would rather plug x equals to 1, b equals negative 5, and c equals 2 into that formula, especially since things are squaring and multiplying and all that. A little easier numbers to do. So take advantage of that when you can. So using our quadratic formula, we get negative b plus or minus, we're going to take b and square it, minus 4 times a times c, all over 2 times a. And then cleaning this up, if we negate a negative, we get 5. Negative 5 squared is 25, and that's going to be an 8 all over 2. And so we end up with 5 plus or minus 25 take away 8 is 17 all over 2. And again, I believe we solved this using the completing the square method. It got a little nasty, but we did it. And if you go back, that's exactly the same solution we got back then. So, and again, there's two answers, right? There's 5 plus the square root of 17 over 2, 5 minus the square root of 17 over 2. So be aware of that as well. So there's our first round of the quadratic formula. Next video, we'll take a look at some harder situations.